Okay, the Igbo Mathematician found something that Grok AI doesn't know yet. It might discover it by stealing information from my computer. Otherwise, so far, it doesn't know. It has to do with permutations. So let's start with a simple question. You ask it to give me 7. Okay, give me permutations for n equal to 7. And this is how it answers it. It answers it row by row. So as you can see here, it was more careful to not make errors, but that's not the main point. Apart from the error, I was wondering the length of time it takes to do the calculation. Now for the simple case, this 7 is trivial. It should take within a blinking of an eye. Okay, but then I wanted it to compare generating permutations row by row versus column by column. And it said that it can do it faster row by row because that's how it was. The algorithms were optimized to do it. The column by column algorithm was not optimized. So as you can see here, it's saying that it was generating the list row by row. And I pressed asking it to generate it column by column, and it performed it. So, but the issue was to know which one was faster. And this is where it explained why row by row was faster for it in this situation. However, column by column should always be faster if you overcome the number of rows limit. I think Libreoffice Calc does not have enough rows for 10 factorial, for example. If you want to display all the rows. So, and that's important because if you're doing something in Python or MATLAB or whatever code you're using, you can't just comfortably, conveniently say display all the rows of 40 factorial or 100 factorial. There are too many rows. But the nice thing for Excel, at least that is Excel or Google Sheets or Libreoffice Calc, the nice thing about a spreadsheet is that within the number of rows it has, and if your computer is fast enough, you can have values simultaneously displayed in the spreadsheet. There might not be all the rows, but at least you have a user interface that will display those values. And if the GPU process gets very smart in parallel processing, the number of cells in a spreadsheet can be mapped to parallel processing, which will make the whole thing very fast because each cell is being calculated independently and in parallel. For I'm just speaking in general for algorithms that allow cells to be calculated independently. The factorial, the permutation algorithm has some dependency on of one cell value to another cell value. It's not completely independent, but still you can try to partition it into parallel processes that will make it even very fast. And the display method of a spreadsheet is very, very good for that idea, instead of trying to do line by line code in Python and so on. So I asked it whether it can generate the permutations without using any macro, because if you're going to use macro, you might as well use Python. And it said yes, but now there's an issue. When it does it, the formulas are not stable in size. So this is what it doesn't know how to do now. You can see it says the proper no macro way using only built-in functions becomes extremely painful after 4 or 5 because Excel has no built-in remove used number function. You end up with monster formulas 300 plus characters long. So and then somewhere else it says use this beautiful trick discovered by Excel MVPs. I'm not an Excel MVP, but I am a mathematician. That's why I'm laughing. And other mathematicians can also try and figure out how to have a stable, constant length formula for generating permutations column by column instead of row by row. Imagine if you had to get 40,320 rows for 9 factorial and you are enumerating them row by row. If you do that in a macro, watching the macro record row by row, that's a large waste of time. That's part of the presentation delay problem. Of course, inside the software and hardware implementation of the calculations, the computer can do permutations like for n equal to 9 much faster than a spreadsheet will be displaying the values row by row. But that's not the point. You can see a similar problem in how the data is being stored. If it's being stored by increasing the number of rows, the computer is still going to wait until it has populated all the rows, versus if it's being stored by increasing the number of columns, it will just wait for 9 columns versus waiting for 40,320 rows. Okay. So we get to this conclusion. So you do not have a constant length formula for direct column by column generation of permutations, and it agreed. All right. Let's see what I have. So for example, let's say we want to do 4 factorial. Okay, permutations for n equal to 4. All right, these are indices to guide the permutation. They are not the permutations, but over here in this sheet called permutations, you can see for 4 you have 24 factorial. Okay, starts from this second row down to here. There are 24 things that make up permutation for an element of, for a set of 4 elements. So when you come here, you should only select 24. Let's see, where am I? Okay, yeah, should only select 24 rows. So the formula is used to fill up the cells, so you don't select too many rows when you come to take your answer. Just select the number of columns and number of rows. In this case, 24 rows and 4 columns. Okay, let's change. Let's try 7. Okay, and you can see it goes up to 7. It goes up to 7, and you should have 5,040 rows to pick from this table out of everything the formula gives. So we can go to 5,040. Sorry, it is jumping too much. Here we go. So you can see the row starts from the third row. The first 2 rows are just like titles, headings. So it goes to 5,040 rows here. Okay, so let's try another one. Let's try 8. So you have 40,320 rows to expect. So what I did here was to take a sub list of the set of elements to permute, and then do combinations and permutations to get the whole list, because as I said before, Libreoffice Calc cannot display 10 factorial number of rows. For example, this formula, the formula I'm using to generate these columns, will give all the rows for a column. for a column, it will give all the rows, but you don't have sufficient amount of rows unless the people who do who create LibreOffice Calc, or the people who create Google Sheets or Microsoft Excel increase the number of rows they make available. And then, of course, as I said before, with a parallel processing method that can calculate each cell independently and in parallel, one can make a spreadsheet extra powerful. In this case, the particular formulas I'm using, one column depends on the previous columns. So you don't have complete independence, but when you look at the rows of that column, you have some high level of independence within the rows of a particular column. So when the number of rows get very, very high, the ability of a spreadsheet to map its calculations to parallel processing units will be a very, very powerful method. So about the sublist, I'm taking it 8 elements at a time. So this is full. The idea is to, let's say you have 12 elements, you break it up into 8 and 4. So one subset of 8 elements and a subset of 4 elements at a time. So basically, you take one list of 8 elements, permute it, and then go to each row of that permutation and take the complement of that list. So in this case, let's say we take the first row. So the first row is the third row here. These are headings. So the first row in the permutation is this third row here. So let's say we take the first row, 1, 2, 3, 4, 5, 6, 7, 8. Then the complement will be the first 4 numbers here. It will have these numbers, okay? And that is what will appear in the second sheet for permutation. So that's the strategy. Now that you have done this heavy lifting, a macro can be used to generate pages. Instead of a macro being used to generate row by row by row, and you are waiting forever as though it's going to take forever, and you don't have time to wait forever for it to finish. So here you take 8 elements, permute it, go row by row with a macro, or if you want just to play around, you can go manually, adjust this. So now we take the other row, the second row, which let's match it. So the second row has 8 and 7 flipped, okay? And that means you just have 9 to 12. you still have 9 to 12. Okay, so second row has 8 and 7 flipped. Let's take the row at the 100th row. Okay, what is it lacking? What does it have? It doesn't have 6, for example. Does it have 6? No, it doesn't. Oh, sorry, it has 6. What does it not have? I saw 6 here, sorry. Okay, so far it seems to be they seem to be contiguous. Is a contiguous. Consecutive numbers 1 to 8 are present here. That's what I meant. Let's see if we can get let's try 200. Okay, so now if we want to get another combination to select here, because what's happening, this is taking all the permutations of this. That's why, because the first group of 8 numbers are basically contiguous. The first group of 8 numbers, 1 to 8. Okay, so if you want to get a collection of numbers that not all of them are contiguous, like this second row, or let's see, we can even use this one, right? So basically what I'm doing is I perform all combinations of length 8, size 8 here. Then I take one of the rows here and permute to make this 8-element permutation. Then I take one of these rows in the first permutation results sheet and get the complement so that we can finish the permutation, because remember we have 12 elements, not 8 elements. Okay, so we take this, get the complement that we omitted from here, and permute them in the second permutation sheet. Okay, then you continue like that, cycling through. You can do that with a macro. So let's say we use another combination, because what we are using is the first row in the combinations. So let's try a random row. So from here we can do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, about 13. Okay, the 13th row also, or the 12th row, I think it's the 12th row, whichever one it is, but you can count it yourself. Let's see, 12. So as you can see, we have different numbers here now. Okay, let's verify where this starting row comes from in the combination. Okay, so it's over here. So this is a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, sorry, I wasn't counting it. This thing has a header. This is not one of the rows. Yeah. Okay. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 13. So let's see what the correspondence is. So you have 1, 2, 3, 4, 5, 6, and then you have 9 and 12. So the numbers that are not in, following the pattern 9 and 12. So over here in combination, you want 9 and 12 right here. So that is what I was selecting. So don't get confused with the index. The index is just for selecting a row. That's why 1, 2, hold on. Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, actually, yeah, I got it. So it's at the 12th row. I was confusing myself. So, but either way, that's not the main formula. The main strategy that I'm showing you here is I get the combinations. Yeah. I take a row from the combinations. Then I make the permutations for that row using only 8 elements. And then to complete the enumeration, because you are missing columns, there should be 12 columns. Okay, I take one row at a time from here and obtain the complement of that row, which should have 4 elements, and permute those 4 elements here in the second permutations sheet. Okay, let's try it for 13 when n is equal to 13. Now, when you are using this sheet, you have to be careful, because just before I show you n equal to 13, if we do 8, there will be only one row in the combinations, because 8 choose 8 is 1. So you have to be careful and make sure you take the first row. The 12th row will give you nonsense. Okay, so going back to 13, for example, we take 8 elements out of 13. So I had set it to the first row. I can set it back to the 12th row of the combinations. You go to the first permutations sheet. You have 8 permutations of that row. Okay. And then you take the complement of this sublist. you go row by row and grab the complement of the sub list. For example, let's take the row here, right? And then we get its complement of 4 elements, and we permute it in the second hold on, yeah, it's not 4 elements because we are doing 13. I was thinking 12. So the number of elements you pick here will be 5, right? So these are the numbers you expect to see in the second permutations sheet, and that's what you have happening here. You permute a 5-element list. Okay, you see the formulas are adjusting the values automatically, and a GPU process that handles the parallel processing will be able to do it quickly, leaving the problem to be how much memory can you have for presenting the spreadsheets of all the cells simultaneously. So this way you can even go, I restricted it to go up to 16 for n. So at 16 you will be choosing 8 at a time for the first permutation sheets, and the complement of that sublist will be another 8 element sublist for the second permutations sheet, as you can see here. 8 here, 8 here. So basically, if you write a macro with this 2, you can create pages and pages of permutations, because the formulas that I'm using here are generating the permutations column by column instead of row by row. Okay, if you write a macro to generate the values cell by cell, that macro will be very, very slow. To be it might be a little bit, or I've not measured, it might be faster doing it row by row, but it's still going to have to populate the cells cell by cell. But if you already populate the sheet with the stable formula that I developed for this too, then all you have to do is just change parameters here, like if you want n to be 15, if you want to take a particular row from the combinations, you change the parameter, whatever row it is. Okay, so you can just step through from 1 to whatever. So for combinations, you have to step through from 1 to n choose k. 15 choose 8 is 6,435 rows. Okay, you have to step through all these rows, get the corresponding 8-element permutations, and then for each row in the 8-element permutation, you have to get the complement of the sublist. Okay, so this is how you select the row from the first permutations sheet in order to get the complement of this list. I mean of the complete list up to 15. Okay, which means the rest of the 7 elements in this case, and that is what will then be permuted in the second permutations sheet. So you can now see how large how quickly the storage requirement grows. And for bonus, there are other ways to make permutations. You can use circular permutation, like here you have this involution and then you start performing circular permutations. You see, add this here, then you do a circular permutation. Here. So when I say circular permutation, I mean the number, the extra element you added, you're shifting its location. That's how you grow the list. So you have this for 2 factorial, for 3 factorial, and for 4 factorial. You have this, but this is also by itself, it's row by row. So it's another way to easily make permutations if you want to do permutations by hand. However, if you are going to do large permutations which you can't have enough time to perform by hand, then there is something the Igbo Mathematician knows that Grok AI does not seem to know yet, apparently.